Welcome to this advanced tutorial on Microtask Queue. By the end, you'll understand how JavaScript's event loop prioritizes microtasks over macrotasks, how to create and manage them, and how to avoid common pitfalls. Let's dive in. So what exactly is Microtask Queue? It's a special queue in JavaScript's event loop that handles promises, mutation observers, and queue microtask operations. The key points are: first, it has higher priority than the callback queue; second, it's processed after the current script execution completes; and third, it can starve the callback queue if not managed properly. Now let's compare Microtask Queue with callback queue. Microtasks execute before macrotasks. Microtasks include promises, mutation observers, and queue microtask operations, while macrotasks include set timeout, set interval, and I/O operations. The event loop has specific phases. First, it executes the current script. Then it processes the microtask queue. After that, it may render if needed. Then it processes the callback queue, and finally it repeats this cycle. Let's look at this code example. First, we log start. Then we create a resolved promise with a then handler that logs microtask1. Finally, we log end. Notice how the promises then handler goes into the microtask queue. Here's another example using queue microtask. First we log before microtask. Then we use queue microtask to add a function that logs microtask executed. Finally we log after microtask. This demonstrates how we can explicitly add tasks to the microtask queue. This example shows how DOM mutations create microtasks. We create a mutation observer that logs when the DOM changes. Then we create a div element and observe it for attribute changes. Finally, we set an attribute, which triggers the mutation observer callback in the microtask queue. Here's an example of microtask chaining. We start with a resolved promise. The first then handler logs first microtask and returns another promise. The second then handler logs second microtask. Each then handler creates a new microtask in the queue. This example clearly shows the priority difference. We log start, then set a timeout for 0 milliseconds, then create a promise microtask, and finally log end. Notice how the microtask executes before the macrotask, even though the timeout is set to 0 milliseconds. Be careful with this pattern. We create a function that adds itself to the microtask queue. This creates an infinite loop of microtasks. The set timeout callback will never execute because the microtask queue never empties. In a real application, microtasks are useful when you need to perform multiple state updates before rendering. For example, when a user clicks a button that triggers several state changes, using microtasks ensures all updates complete before the UI renders. Another practical use is processing large data in chunks. By breaking the work into small microtasks, you can process data without blocking the main thread, keeping the UI responsive. Let's compare microtasks and macrotasks. Microtasks have higher priority and are processed after the current script completes. They're used for promises, DOM mutations, and queue microtask operations. Macrotasks have lower priority and are processed after the microtask queue is empty. They're used for set timeout, set interval, and I/O operations. Now let's compare queue microtask with promises. Queue microtask is an explicit API that's slightly faster but has no promise overhead. Promises have more familiar syntax and built-in error handling, making them more widely supported. Here's a common mistake. The wrong way creates a microtask for each item, which could lead to Stack Overflow. The right way processes items one at a time, creating a new microtask only after the current one completes. Another common mistake is creating infinite loops in microtasks. The wrong way shows a promise that enters an infinite loop. The right way processes some work and only schedules the next chunk if needed. Here's a pro tip. Use Queue Microtask when you need explicit microtask scheduling and maximum performance. It's slightly faster than creating a promise just for the microtask. Another important tip is to limit microtask creation. If you create too many microtasks, you can starve the callback queue, which can lead to unresponsive applications. When using async/await, remember that each await creates a microtask. While async/await makes your code cleaner, be aware of the microtask implications, especially in performance-critical sections. That concludes our deep dive into Microtask Queue. Remember, the Microtask Queue has higher priority than the callback queue, includes promises and mutation observers, and can be explicitly scheduled with Queue Microtask. Be careful with infinite microtask creation, and use Queue Microtask for explicit scheduling when needed. If you found this tutorial helpful, please like and subscribe for more advanced JavaScript content. Thanks for watching.